Hello, dear students. How are you? I hope you are doing good. So, I welcome you all in this discussion session of AIT 3 NEET examination physics paper. So, I have selected some problem on your recent exam of AIT 3 NEET, and we'll be solving that questions here and see the concept behind it. Okay. Without wasting so much of time, let's just get started. Now, the very first question is this. So six charges of same magnitudes and the magnitude of the charge is, let's say, Q, that is given to us. Just a second. So six charges of same magnitude Q are placed at the sixth corner of hexagon of side A. The potential difference at the center of the hexagon will that we have to find out in this question. Now, let me just start solving it. So in this question, what is given to us? There are a hexagon which have six sides and the six sides are equal. So all the charges are placed at the corner of the hexagon. This is center. Now, what is the potential difference at this center? So for that, if I just want to calculate from this charge, what is the potential at this point? We need to calculate the distance of what is the distance of this charge from the center, and for which we have to calculate this length. We know that the length of hexagon is given by the side is given by A in the question. So this length is A and this angle is 60. This angle is also 60. So this angle also is 60 because sum of all the angles in a triangle will be 180. So this will become an equilateral triangle, which means that this side is also equal to this side, which means the distance of any charge from the center is A itself. Got it? So what we will do here? Now potential due to one charge we will calculate, which is nothing but KQ upon R. Okay, which is KQ upon A. Now, if I just multiply six number of charges, so it will give me the VQ. There will be no effect of the direction because potential is a scalar. So wherever the charge is present, if the distance from the point is same, the potential also will be same. Yeah, so the total potential is equals to 6 times of VQ, which is 6 KQ upon E. This is the correct answer to this. Option D is the correct. I hope you got it. Now move to the next one. The electric potential V, at any point XYZ, all in meters, is given by V is equals to 4x square volt. The electric field at the point 1, 0, 2 in volt per meter is. So in this question, there is a potential expression is given to you, which is 4x square. Now we want to calculate the electric field in this expression. Now we easily know that very famous expression we know that dV is equals to minus of E dot dr. Okay. From this expression we can also conclude that dV by dr is equals to minus of E. So if I just differentiate this expression with respect to dV by dr will become minus 4 into 2. Okay. So it will become minus into 8x, minus 8x. This dV by dr is nothing but minus E. So this minus and minus will cancel up. But since this E is a vector quantity, so I have to apply the vector sign and the magnitude is coming only in one direction. So I can write, and this is positive also, so E vector will become 8x IK. So at this point, only x coordinate you can put in this expression, because there is no y coordinate and there is no z coordinate in this expression. So E at 102 will become 8I, and this is plus 8, which means the electric field will be of 8 volt per meter and in the direction of positive x-axis. So it will be option B is the correct one, 8 along positive x-axis. I hope you got it. Now move to the next one. If the current through 3 ohm resistor is 2A means 2 ampere, then the power dissipated in 4 ohm resistor will be. Okay. So here we will see ki in this circuit, the current through this is what? 2 ampere. The current will be different in this because these are in parallel combination. And this is the total current. Okay. So we want to calculate what is the power dissipated in 4 ohm resistor. The power dissipated in this. Clear? Now, if I just calculate the potential difference across this 3 ohm resistor, can I do that? Because I also know in 3 ohm, which is 2 ampere. What would be V? So V at 3 ohm ampere will be I through that particular resistor and the value of resistance itself. So I is 2 ampere and this is 3, the value of resistance. So it will become 6 volt. And since these two are in parallel combination, so whatever the potential difference across 3 ohm resistor, the same will be the potential difference across 6 ohm resistor. So at 6 ohm resistor, the potential difference is 6 volt. So we can calculate the current through 6 ohm resistor multiply by the resistance itself. So it is 6 I into 6 ohm resistor multiplied by value of resistance is 6 ohm. So I into 6 ohm resistor will be 1 ampere. So the current that is flowing through this 6 ohm resistor is 1 ampere. Now you can easily calculate what is this value of this I. Since 2 ampere current is flowing in 3 ohm resistor, or let's say in this branch 1 ampere current is flowing into this branch 2. So this will be a nodal rule you can also apply, and very common sense is that the current will be getting a sum up value. So 2 ampere plus 1 ampere. So the current in 4 ohm resistor, current in 4 ohm resistance will become what? Let's say it is denoted by capital I. So it will become 2 plus 1 is 3 ampere. Okay. Now power dissipated we can easily calculate. Power is nothing but I square into R. Now I square you have to take for 4 ampere. So it will be 3 square multiplied by R is what? The value of resistance itself. So it will become 9 into 4 is 36 watt. Option D is the correct answer. I hope you got it. Now move on to the next one. 3 large parallel plate capacitor have uniform surface charge densities as shown in the figure. What is the electric field at T that we have to calculate? So first of all, if the distance is given to you in these types of arrangement of sheets, this distance is regardless anything. It doesn't mean that you have to include this. So the very common thing or very sensible thing that you have to remember is, if everything is given in the question, you do not have to use everything in the question. So here we know that when we have a plate having surface charge density sigma, so the value of electric field is given by sigma by epsilon naught, and it is independent of the distance from where you are calculated from the sheet. If the sheet is infinitely large. Okay. So that is why this distance J is nothing for you. Okay. So we want to calculate the distance at this point P. Got it? So point P पे there are three seats having charge density sigma, charge density minus 2 sigma, and charge density minus sigma. So there are two methods that you can use here. The method one, you can get a calculated, you can calculate the net electric field at this point P. First of all, we do that. Net electric field, net electric field at point P. So it will be the sum of multiple electric fields present here, and multiple electric field will be given by this sigma upon epsilon. So from this sheet number 1, let's say this is sheet 2 or plate 2, and this is plate 3. So we have electric field E1 plus E2 plus E3. We have to put that according to the sign given in the charge density, because the sign of the charge density represents the direction of electric. Even here we can say minus sigma upon 2 epsilon naught. So this will be 2 epsilon plus minus 2, sorry, plus, sorry, minus 2. Just a second. It will become minus 2 sigma upon 2 epsilon naught minus sigma upon 2 epsilon. So if you get a sum of this value, it is coming out to be as, this is plus sigma, this is plus sigma. This will cancel out this. So you have a value of minus 2 epsilon naught, 2 sigma upon epsilon naught, 2 epsilon naught. So you can say that one option having a, this thing is missing here. Or, okay. So minus 2 sigma upon 2 epsilon naught, this is the electric field at the end. Okay. Now, move on to the next. This one. Find the current in 9 ohm resistor in the circuit as shown. Now, in these types of a circuit, first of all, the first method that you can use to solve this kind of question. First method. First method is KVL, which is Kirchhoff's voltage law. Okay. That you can use. There are two loops given in the question. You can apply the KVL, but KVL will be a bit lengthy in these types of questions. So it's better to apply KCL. KCL is what? Kirchhoff's current law. Okay. Now, Kirchhoff's law, why it is easy for here to apply? Because there is only one battery and one load resistance. One battery, and load resistance. So this would be a pretty simple circuit to apply the Kirchhoff's voltage, Kirchhoff's current law. So what we will do, we will take a node or a junction. Here is the junction. Let me draw it first. And here we have only a battery. Okay. So here we have a junction, and this point also we have a junction. Okay. But when you move at this point, you will firstly encounter a resistance. So it's better if you encounter a battery first of all. It's better to write the potential difference for the battery. So here what we will do, we will distribute the current in these three branches. Let's say I1, I2, and I. So applying, let's say this point is C. So applying KCL at point C. So it will become I1 plus I2 plus I3 is equals to 0. So I1 is what? This is 10 volt, 3 ohm is the internal resistance, 2 ohm is the load resistance. So total we can say these are connected in series, so 5 ohm resistor is there. Similarly, for the middle branch, the resistor will be 10 ohm. And here we have 25 volt of the battery and 4 ohm is the resistor. So can we say that I1 is nothing but I1 is generated due to the potential difference at point C and this point, let's say. So we want to find out the current in 9 ohm resistor, this ohm. So for that we need to know what is the potential difference at this branch. So suppose potential difference at point C is, let's say, V. Another we have to calculate in this. So this current I is flows. Look. So from here to here we can write the potential at V minus V. How do we write the potential? Let's say we have to write VAB. So how do we write it? VA minus VB. Clear? Now, similar thing you can apply here. This point potential minus this point potential. V minus 10 volt battery is present. V minus 10. Okay. Divided by what is the value of resistance that you are having? Upon 5. Because I1 is given by V1 upon R. Okay. That method we are using. Similar for I2. So it will be V minus potential difference of the battery is 15 volt divided by 10. Why I am not writing the potential at this point? Because it will be common and cancel out for each and every. That is why I am not writing. Now, similar for this, for I3, there is a slight difference because everything that you are writing here, V minus VA minus VB form. So this is always positive plate you are hitting with the battery, but this time you are hitting a negative plate of the battery. Or you can say this particular battery is discharging. So in this case, the potential difference will become V minus minus 25 divided by 4 equals to 0. So this will become V minus 10 upon 5 plus V minus 15 upon 10 plus V plus 25 upon 4. So you can multiply with 20 over here. So when you multiply with 20, why we are multiplying with 20? 20 is the LCM of the denominator. So it will cancel out the denominator. So it will become 4 times of 5 for the 20. 4V minus 10 plus 2V minus 15 plus 5V plus 25. So from here, if you calculate what is the potential at this point, so you can say that 4V minus 40 plus 2V minus 30 plus 5V plus 125. This 40 plus 30 will become 70. And when you subtract 70 from this, it will coming out to be as, and this will become 4V plus 2V plus 5. 4 to 6, 6 plus 5 is 11. Okay. Now, divided by equals to minus 40 minus 30, 70, and this is 125. 125 minus equals to 5, and this is also 5. So we will here become minus 55 minus 5, which means the position of the potential that we have described here is opposite, which means the current from the second branch will flow opposite to the direction because this is minus 5 volt. Okay. So potential at this point is coming out minus 5 volt. Now we have to calculate I2, the current in 9 ohm resistor. So I2 will become V minus 15 divided by 10. And V is what? Minus 5. So minus 5 minus 15 will become minus 20 by 10. So this will cancel out. So it is minus 2 ampere, which means the direction of the current is only you have to reverse. In the previous case, we have assumed this is the direction of current. In this case, you have to assume this is the direction. The correct direction is this. So your answer also will tell you that you have assumed the right direction or wrong direction. Clear? Now, so option C is the correct. The plates of area A are arranged as shown. The distance between each plate is D, the net capacitances. So these types of arrangement has a trick to solve, and we will see and we will elaborate this trick in this question. So whenever you see these types of arrangement of plates, you can see here, if I just redraw it, B, let me make it a bigger one. Okay, and this. Yeah. So first of all, you can see here that if these two are the plates, there is a capacitance between them. Parallel plate capacitor will be formed. Let's say C1. These are also two plates, this and this. So one of the capacitor will be forming it in between them. This is the plate here and here. So one of the capacitance is forming in between them. And another plate is this and this. So one of the capacitance is forming between C1, C2, C3 and C. So there are four resistance that is be deriving from these types of this equation or this arrangement. This arrangement consists of four capacitor. This we have seen in this particular arrangement have four capacitor. Now how to solve this? So first of all, the method I am going to discuss here. Okay, this is A and this is B. So we have to find the net capacitance between A and B. It should be mentioned here, but we are considering that we have to find out the net capacitance between A and B. Okay. So first of all, do the numbering of the plates, but start the numbering from inner side, not from the outer side. So let's say this is 1, 2, 3. This plate ka other side will be also having a number. So 1 is for inner, 2 is for the outer of this, 4 is the inner for this. Okay. 5 in front of 4, 6, 7, 8, 9. So total 9 number we have done. Now what you have to do? 1, 2, one number I have missed here. Just give me a sec. 1, 2, 3, 4, 5, 6, 7. Okay. 1, 2. There are number of plate you can count 1, 2, 3, 4, 5. So here we have 1, 2, 3, 4, 5. Okay. The numbering of this plate is 1. Then this is 2, 3, 4. 5 is for this. 6 and then 7 and then 8. You always have a even number in this. So that is why I'm checking it again and again. Okay. Now what you have to do, you have to make the pair of these. So how many pair of you have the four lines? Okay. This is 1, 2, 1 pair, 3, 4, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. So these are the pairs that we are. Now 2 and 3 is also connected with these. 2 or 3, this line. Let number them also 1, 2, 3, 4, 5, 6, 7. Now connect those plates whose has a odd numbering like this 2, 3, 4, 5, 6, 7. Okay. So connect them with the line 2, 3, 4, 5, 6, 7. Okay. Now connect like this. Clear? Now what we will do, we will see that which number is connected to which plate. So here we will see that this 6 7 junction is connected to terminal A. Note it. This one plate is connected to, this plate number 1 is connected to 4 or 5. So we can say that plate number 1 is connected to 4 and 5. Now this 2 3 plate is also connected to 8. So 2 3 plate is also connected to 8. So we have a rough sketch of the connection here, and the connection for B is also given by 8. So this plate is also connected to B. So plate 1 is connected to B, and plate 1 is also connected to 4 and 5. So here you can say plate 1 is connected to B, and plate 1 is also connected to 4 and 5. Now draw these two terminals. Let's say B and E. Now place those plates near to point B and connect them which are already connected to point B. Look, here we have seen that this plate 1 is connected to B, and by this connection, this plate 4 and 5 is also connected to B. So we can say that this is plate 1. This is plate 4 and 5. So 4 and 5 are connected with each other, and then they are connected to point B. And this point, this plate 1 is also connected to this point B. Clear? Now, if I see that in front of 1, there will be always 2. In front of, this is 4, this is 5. In front of 4, there is always 3. In front of 5, there is always 6. Now, right, do the same for this terminal A. So terminal A के साथ we have connected 6 and 7. This is 6 and this is 7. In front of 6, there is what? In front of 5, there is 4. Let's say, just a second. So the plate 4 is connected to this terminal, and in front of 4, there is 3. There is a combination of 3 4, combination of 5 6. Okay. Now we can say that only one plate is connected to, 2 plates are connected to 7. This terminal A. So plate 7 is connected to terminal A, और 7 के front में कौन सी plate है? This is plate 8. Okay. And this plate 6 is also connected to terminal A like this. So 6 7 plate is connected to terminal A. They are connected. Now this plate 8 is also connected to 2 and 3 combinedly. So we can say that plate 2 and 3 connected with each other, and then they are connected to terminal A. So for simplification, we can do the right. So if you see these two connections, these two capacitance are in parallel, and then the equivalent capacitance of this will be series and with this 8 7 capacitor, and then they are in parallel. So we have sorted out this particular capacitance circuit. So here we have like this, and again one of the plate is like this. They are connected in parallel. This is terminal A and this is terminal B. Yeah. This parallel combination will be, each capacitance is of, let's say, C. Okay. Because same area की plate है, so capacitance will also be same. So C and C will be what? The parallel combination will become C1 plus C2. So it is coming out to be 2C. A and B. 2C, C and C. 2C and C is in series. So they will be 2C by 3. 2C by 3 is the capacitance. Then C. Now, if you take these two capacitance combined, so equivalent capacitance that you are having, C equivalent is 5C by 3. And when you explore the value of C also, it will become 5 epsilon naught A by D. Okay, 3D. Now, in this question, the correct option is option D, but it is also have missed this 3. Okay. The correct option is 5 epsilon naught A by D. This is the printing mistake that we have. Now this one. Following figure shows that the path of an electron that passes through two regions containing uniform magnetic field of magnitude V1 and V2. Its path in each region, its half circle, choose the correct option. So we know that the magnetic field in any region when the particular when a charge particle moves in a magnetic field, the Lorentz force will be acting on this and it will be given by QV cross. So for electron, this force will be minus of V vector cross B vector. Now, B1 and B2 is not given. Okay, what is the direction of B1? But the direction of velocity is always given to you. If I talk about this B1, the electron is entering in this profile or in this region with a horizontal velocity. So this is the velocity. So what type of force can make this path? The force must be like this. If you will see, this is a circular track that is making. The force will be like this, always perpendicular to the velocity. So always perpendicular to the velocity, the force will be either in this direction or in this direction. Got it? And since it is making a circle in this plane only, so the possible direction are this and this. And if you see the moment of velocity, then only you can say the possible direction of the force will be like this. Okay? Which means if you curl your finger and try to find out what is the direction of this B itself, so for this force, so if you see the direction of velocity and you curl your finger like this, okay, then you will see B cross B is downward. Okay. It's only possible either the B is inside or B is outside. But for B is outside, the thumb is pointing downward and the similar force we want here to make this circular track. So we can say that B is inward. Okay. Now, which of the field is greater? So we know that the radius of the circular track that electron will make is mv upon bq. It is given by mv upon bq. And for the case of electron, it will be b. Okay. So in this case, this force is for the normal charge, but since this is electron, the force will be in opposite direction for the inward field, which means if the field is outward, then you curl the finger, then the force is pointing downward. Clear? But the R here is depending on the magnitude of B, which means more is the magnitude of B, lesser is the radius. And you can see in this question, in B1, the circle is lesser wide than the circle of B2, which means that B1 having greater magnitude than B2. Okay? Clear? And B1 and B की direction में move करेंगे perpendicularly curl करोगे fingers को तो the pointing direction is downward. If B is outside, which means for electron the B is inside because the direction of forces changes of the electron for the electron. Okay. So B is what? Inside of the B. So B1 is into the phase and it's stronger than B. Okay. Option A is the correct. Now move to the next one. A current loop ABCD is held fixed on the plane of the paper as shown in the figure. The arc have radius r and nr, magnitude of magnetic field at common center of the arcs. So it's very simple case. You just have to remember this formula. The magnetic field due to a circular arc having a current is, or you can say current carrying circular arc. Okay. So magnetic field is given by mu naught I upon 4 pi r into theta. Theta you must put in the form of radian. Okay. So for this small AB arc, you have to curl your finger to find out the direction of magnetic field in the direction of current move. So current is moving like this, curl your finger, so B is pointing inward. So inward we will take minus mu naught I upon 4 pi. What is the value of R? It's small r. What is the value of theta? It is pi by 6. 30 degrees pi by 6. For B2, this is for B1. For B2, same thing will be there because current is same, but the radius has been changed. So it will be 4 pi n r into pi by 6, and minus sign is also here. So B net here is B1 vector plus B2 vector. If I add just the magnitude over here, because sign is also mentioning the direction, so minus mu naught I upon 4 pi r into pi by 6 minus mu naught I upon 4 pi n r into pi by 6. Pi se pi will cancel out. So it will become mu naught I upon 4r into 1 minus. You can take the minus also common. So it will become 1 upon 1 by n. And multiply the n here. That will become minus mu naught n plus 1. Just a second. Minus mu naught I upon 4 into this 4. 1 by 6 is also there. 1 by 6 for pi by 6. So it will become 24r. Now you can say here that it is mu naught I upon 24r into n plus 1 upon n. So we can say that minus mu naught I upon 24r n plus 1 upon nr. So here the incorrect option is this. Okay. No. This option is not incorrect. We haven't mentioned the direction for B2. So for B2, the direction is outward. So that is why it is considered as positive. When it will be positive, then the sign here will be becoming as n minus. So option is correct. Option B is the one. Now, two coils having self-inductance L1 4 millihenry and L2 is equals to 1 millihenry respectively. The current in the two coils are increased at the same rate. At the certain instant of time, both coils are given the same power. If I1 and I2 are the current in two coils at that instant of time, respectively, then the value of I1 by I2 is. So we can say that here two things are having a primary focus. Two coils are the same, increase at same rate. So current rate is same for both the coil. Di by dt for one is equals to di by dt for second. And for a particular instant, power is also same. And that instant also it is asking for the ratio I1 by I2. Okay. Now we know that power is nothing but, सबसे पहले we also know that the EMF in the due to self induction is given by L into di by dt. Okay. Now, what is power? So from here, because we want to calculate the ratio I1 by I2, so we will take this LS because it is different for different coil. So for L1, it is epsilon 1 di by dt. Why I am putting it at di by dt? Because the current rate are same. And for L2 also, It will become E1 upon di by dt, and L2 also epsilon 2 upon di by dt. Now you take the ratio L1 upon L2. It will become epsilon 1 upon epsilon 2 because di by dt will get cancelled. Epsilon 1 you can also write as, in terms of power, we can use this power utilization here. Power is nothing but V square upon R, or what we can say, it is V into I. Clear? V is nothing but the epsilon 1 for this first coil. So we can also write it power 1 P1 is equals to epsilon 1 into I. Okay? I1. So if you put the value of epsilon 1 in terms of power, P1 upon I1. So put it here, P1 upon I1, P2 upon I2. So it will become I2 upon I1, P1 upon P2. P1 and P2 are also same. So we can say that L1 upon L2 is I1 upon I2, or we want to find out I1 by I2. So I1 by I2 is L2 by I2. It inversely depends on the inductance of the coil. Yeah. Self-inductance of the coil. So it is, and the value of L2 and L1 is also given to you. What is the value of L2? It is 1, and value of L1 is 4. So ratio will be 1 by 2. So option B is the correct. Now this, the equivalent resistance between the point A and B is. So if I just draw it correctly, just need a little modification in this circuit. This is option A, and this thing you will grab because of your practice. Yeah, the more you will practice these types of circuit, the more you will be confident about these types of circuit. And you have a clear idea about just by seeing the circuit. Like this, like this, like this, and like this. So if you see this circuit very clearly, something Wheatstone bridge is forming here. If you will see, something Wheatstone bridge is forming in between these two. We can make this circuit like this also. This is point A. These two resistance are connected. Then one of the resistance is in between them. Then again two resistance. And then is one more resistance. Point. This resistance is same as this. Value of this resistance is 6 ohm. This is 8 ohm resistance. And this is 10 ohm in middle branch. This is 3 ohm. And this is 4 ohm. And the last one is 7. So for balanced Wheatstone, what you will see? First of all, you have to check the ratio of the diagonals resistor. So ratio of 6 by 8 is equals to ratio of 3 by 4. So 2 3 is 6. 2 4 that. So both the ratio are same. So we can say this is a condition for balanced Wheatstone bridge. So in balanced Wheatstone bridge, this middle branch will be vanish out. There will be no current in this middle branch. So it's very simple now. These two resistance are in series. These are also in series. Then they are parallel, and then they are in series. So for this series, 6 plus 3 is 9. And here 8 plus 4 is 12 ohm. So this is 9 ohm. And this is 12 ohm. Again, they are in parallel, and then they are in series with 7 ohm. So in parallel, what it will be? 12 into 9 divided by 12 plus 9. So 12 into 9 divided by 12 plus 9 is 21. 3 4 the 12, 3 7 the 21. 36 by 7. And when you add with this, you will have this one. Because 36 plus 7. 7 7 49. 49 plus 36 is 85 by 7. So this is the total resistance. This is a clear case of Wheatstone. Now this one. Formula based question is this also. A coil of circular cross section 4 centimeter square having 1000. So these types of question, first of all, try to write what is given in the So given data is what? Number of tons, which is 1000 tons. Area is 4 centimeter square, or we can write 0.04 meter square. Okay. Sorry. 4 into 10 raised to the power minus 4 meters. And magnetic field is decreased by delta B is also given to you 10 raised to the power minus 2. And time is also given in which this field is decreasing. Time is given to you as 0.01. Okay. Now we have to find out the EMF induced in the coil. So EMF induced in the coil is given by minus d phi by dt if the coil is have single turn. But when the coil have multiple turns, so this will be given by minus n d phi by dt. And phi we also know that it is dA cos of theta. And if B is changing, so we can write this delta phi is nothing but delta B into A cos theta. Put the values here. Minus n delta B upon delta T into A cos of theta. Now delta T is also given to you, n is also given to you, delta B is also given to you. Okay. So you have to apply the value for this. And space area is placed with its axis parallel to a magnetic field. So axis is like this, and this is parallel to the magnetic field, which means the angle between the area vector and the magnetic field vector is 0. So cos theta will become 1. Okay. So it is minus 1000. Delta B is what? 10 minus 2. Delta T is also 10 minus 2. Multiply by what is area? Area is 4 into 10 raised to the power minus 4. Nothing remaining. This will cancel out. 3 power will cancel out the 3 zeros. So this will becoming as minus 0.4. Or one thing that you are missing here is the number of zeros here. Okay. This is 4 centimeter square. Meter square may given at 10 raised to the power minus 2. This 0.01 second is also 10 raised to the power minus 2. Okay. So we can have this. Clear? From this, you can calculate the value of the magnetic induced EMF or induced electromotive force in this circular coil. Now move on to the next one. Two long straight conductors carry current 3 ampere and 1 ampere into the plane of paper. A circular path is imagined to enclose these currents. So मेरे पास we have two values of current. Direction is into the plane of paper. Okay. We can have this. These are the current. So in a 3D view, you can say that the current is going like this into the plane. Okay. Into the plane they are going. Clear? One of the current is 3 ampere, one of the current is 1 ampere. So it is asking for what is the value of integral of PDL if I enclose the current in a circular loop. So it's very simple. Integral of B vector dot DL vector, it is given by the Gauss law of magnetic theorem. Okay, na? So it is nothing but mu naught into I enclosed. Okay. Mu naught is mu naught. I enclosed is what? 3 ampere and 1 ampere because both the currents going in same direction. So that is why 3 plus 1. So it is 4 mu naught. So these types of questions just give to confuse you. Okay, na? You don't not be confused. Use the formula, get the answer. Now this one. The resistance of a platinum wire at 20 degrees Celsius and 50 degrees Celsius is 20 ohm and 60 ohm respectively. So at 30 degrees Celsius, what is its resistance? So first of all, we know that resistance at temperature T is given by resistance R naught, the original value, plus into 1 plus alpha into delta T, change in temperature. Okay. Now, if I put the values here, RT at 20 degrees Celsius. So first of all, let's say T1 is 20 degrees Celsius. You need to convert it into Kelvin. So it will become 273 plus 20. 293 Kelvin. So it will become, let's say R1 is R naught into 1 plus alpha into T2 is what? Temperature 2 is 50 degrees Celsius. 50 degrees Celsius is, you also have to convert it into Kelvin. So 273 plus 50. So it will become 0, or sorry, 3, 2, 3 Kelvin. Now, the value that we are measuring here from the base value. Okay. So for resistance at 50 degrees Celsius or resistance at the 60 degrees Celsius, what you will do? Alpha into delta T, take the reference temperature as 0. Okay. Take the reference temperature as 0. Now, if I apply at T is equals to this one, R naught into 1 plus alpha, alpha will not change. Delta T is what? For first, it will become 293. Oh, sorry. Now it's very simple. You don't need to convert it into Kelvin. If it is asking for the difference of temperature, then you have to apply for this. Okay. But the difference of temperature in degree Celsius and degree Kelvin or Kelvin is same. Okay. So when we are saying we are measuring the temperature from 0 degree Celsius to T1 is for first is let's say 20 degrees Celsius. So delta T is what? 20. So R at 20 will become R naught 1 plus alpha into 20. And R at 50 will become R naught into 1 plus alpha into 50. You can take the ratio here. R20 and R50 is also given to you as 20 by 60. R0 and R0 will cancel out. 1 plus 20 alpha, 1 minus 1 plus 50 alpha. If you take the temperature in Kelvin also, so at 0 degrees Celsius, the Kelvin temperature will become 270. So ultimately, this value you have to subtract from 273. Okay. This is 1 by 3. Again, you need to multiply this 1 by 3 into this expression. So try to cross multiply it. So when you cross multiply this expression, it will become as 50 alpha plus 1 is equals to 3 plus 20 alpha, 60 alpha. So here 50 minus 60 is 10, 1 minus 3 is minus 2. Minus 2 is equals to 10 alpha. Alpha is minus 1 by. Now you got the value of alpha. You want to calculate it for 30 degrees Celsius, you can easily do that. So for 30 degrees Celsius, R at 30 degree, it will be R naught. And from there, you can also calculate the value of this R naught. Okay. So when you find the value of this R naught, put it into this expression and get the values of the unknown resistance. Okay. So this is it for today now. I hope that you will enjoy this session. So if any kind of doubt other than these questions you are having also, you can connect to me via the live classes. Okay. So thank you so much, guys. Take care of yourself. Bye bye.